Imagine a world where colossal sea monsters ruled the waves, only to vanish without a trace, leaving behind just fossilized whispers of their reign. Today, we're diving deep into the ocean's greatest cold cases ancient extinctions that still baffle scientists. We're about to explore the baffling disappearances of some of Earth's most magnificent prehistoric marine life. Are you ready to play detective? Our first case file takes us to the Permian-Triassic boundary, an event so catastrophic it's called the Great Die-In. This wasn't just a bad day for life on Earth, it was the apocalypse. Picture this. Over 250 million years ago, a staggering 90% of all marine species were wiped from existence. It remains the largest mass extinction our planet has ever witnessed. So, what happened? The list of suspects is long and terrifying. The prime culprit is a series of volcanic super eruptions in what is now Siberia. These eruptions weren't just spewing lava, they released immense amounts of carbon dioxide into the atmosphere, triggering runaway global warming. As the planet heated up, the oceans became a death trap. This led to our second suspect, the ocean anoxia. The warming waters couldn't hold as much oxygen, effectively suffocating marine life on a global scale. Imagine vast stretches of the ocean becoming dead zones, a toxic soup where nothing could breathe. The third suspect is the rapid climate shift itself, creating acid rain that altered ocean chemistry. But even with these prime suspects, lingering questions haunt paleontologists. Why was the marine realm hit so disproportionately hard? The Great Dying was like a selective murderer, and we still don't fully understand its methods. Were there other, more subtle triggers we've missed? Some specific kill mechanism that explains the precise pattern of extinction remains elusive, a puzzle piece lost to time. Next, we fast forward to the end of the Cretaceous period about 66 million years ago. We all know the story. A giant asteroid slammed into the Yucatan Peninsula, spelling doom for the dinosaurs. But the devastation wasn't limited to land. Beneath the waves, a separate, equally dramatic extinction event was unfolding. The asteroid impact was like a bomb going off in a pond. The initial blast would have sent colossal tsunamis across the globe, and the debris thrown into the atmosphere would have blocked out the sun for months, maybe even years. This plunged the oceans into darkness, causing a catastrophic collapse of the entire marine food web. The microscopic phytoplankton at the base of the food chain died off, and everything that depended on them starved, from the smallest ammonites to the mightiest predators. This is where we see the sudden, shocking disappearance of the true sea monsters. The mosasaurs, giant predatory lizards up to 50 feet long, and the elegant, long-necked plesiosaurs. They were the apex predators of their time, but they vanished in the geological blink of an eye. Yet, amidst the carnage, some groups were surprisingly resilient. Many species of sharks, for instance, managed to adapt and survive. This raises a critical question. Why them? Why did sharks make it through when the equally formidable mosasaurs didn't? This leads us to wonder if there were other unaccounted for losses or compounding factors. Was the asteroid the lone killer, or was it simply the final blow to marine ecosystems that were already under stress from things like massive volcanic activity in India as decant traps? The crime scene is complex, and the asteroid might not have acted alone. Let's rewind even further back to a much older mystery, the Ordovician Silurian extinction, around 445 million years ago. This was Earth's first known mass extinction of complex animal life, and it was a brutal 1-2 punch delivered to the ocean's inhabitants. At this time, life was almost entirely marine. The planet plunged into a sudden and intense ice age. Massive glaciers formed, locking up huge amounts of water and causing sea levels to plummet dramatically. This was the first pulse of extinction. It destroyed the shallow, warm water habitats where most life, like trilobites, brachiopods, and reef-building organisms, thrived. Imagine your entire world, the shallow coastal shelf, simply drying up and disappearing. Then, as quickly as it began, the ice age ended. The glaciers melted, sea levels rose rapidly, and this brought the second pulse of death. The newly flooded continental shelves were hit by our old suspect, widespread anoxia. The changing ocean chemistry and circulation patterns starved the water of oxygen, suffocating the survivors who had weathered the first glacial punch. But what triggered this rapid and extreme climate swing? And why were specific groups of invertebrates so incredibly vulnerable while others weren't? The exact mechanisms that caused this glacial gauntlet and the subsequent oxygen depletion are still hotly debated. It is an ancient enigma that shows just how volatile our planet's climate system can be. So why do we spend so much time investigating these ancient cold cases? Because these prehistoric extinctions are not just stories from a distant past. They are echoes, powerful warnings for our time. Understanding how ocean ecosystems collapsed under rapid warming, acidification, and oxygen loss gives us a crucial framework for understanding the challenges our modern oceans face today. These events show us the tipping points and the fragility of marine life when faced with drastic environmental change. Fortunately, we have tools our predecessors could only dream of. Cutting-edge technologies like advanced chemical analysis of fossil shells and sophisticated climate modeling are helping us piece together clues that were previously hidden. Interdisciplinary science, combining geology, chemistry, and biology, is allowing us to revisit these cold cases and uncover new evidence. We are getting closer to solving these ancient mysteries, one fossil at a time. But the story isn't finished. The ocean's past is a vast crime scene, and there are still so many unanswered questions. What do you think? What's your theory on what really happened during these great extinctions? Let me know your verdict in the comments below. The story of life is a story of resilience, but also one of incredible fragility. A lesson written in the stone of our planet is the vast oceans. Thanks for watching, and if you enjoyed diving into these mysteries with us, don't forget to like and subscribe for more deep dives into the history of our amazing planet.